Okay, so now we're going to get into Chapter 5. Recall Chapter 4 we learned quite a bit about polynomials, adding, subtracting, multiplying, dividing polynomials, identifying terms of polynomials, coefficients of polynomials, the degree of each term, the degree of the overall polynomial. We had some special names for them: monomials, binomials, trinomials, and just the general name polynomial. So now we're going to get into something that's really, really important, and you really have to understand excuse me, about factoring. All right? So let's go ahead and start with section 5.1, which is on the greatest common factor and factoring by grouping. Okay, so the first thing that I want to do is to find the GCF for two integer values. Okay, so let's find the GCF, so the greatest common factor. Now, this is a little bit different than finding the LCD. Remember before we found lowest common denominator when we were dealing with fractions? So this is the greatest common factor, all right? So it'll look similar to what we did before. So let me write this down. Let's say the numbers are 36 and 24. And what's similar is that we're going to break these up into prime numbers. So 36 is 12 times 3, 12 is 6 times 2, 6 is 3 times 2, and then we're going to circle all of the prime numbers. So this should look familiar to you. All right. Then 24 is 12 times 2, 12 is 6 times 2, 6 is 3 times 2, and then we circle all of our prime numbers. Okay? Now, what the greatest common factor is you're trying to find the largest number that's going to go into both 36 and 24. Okay? So we know that 2 goes into 36 and we know that 2 goes into 24, but that's not the largest number that goes into both of these. Okay, so excuse me. So how we do this is let's write 36 into exponential notation, and that is going to be 2 squared times 3 squared. So the 2 squared comes from right here, and then the 3 squared comes from these two 3's. All right? And then 24, written in exponential notation, will be 2 cubed because of the 3 2's right here, and then times 3 from this 3 right there, right? Okay, so now what we're going to do is we're going to look and see what's common. So remember, it says greatest common. So let's find out what's common. Well, what's common is we know that we have a 2 and a 2, all right? And we also have a 3 and a 3, okay? So that's common. So what do I write down? I'll go, okay, the GCF equals, and I'll put my two numbers that are common, a 2 and a 3, so 2 times 3, all right? Then you pick, okay, it's very simple, you pick the smallest exponent out of each individual exponential notation for each number. So for 36 and then 24. So on the 2, the smallest exponent is 2, so that's 2 squared. But we come over to 24, and you look at the 2, and it has a cube on it. So what's smaller, the squared or the cube? Well, the square is. So I put 2 squared. Okay? And then I look at the 3. So out of the 36 and the 24, you compare those two 3's, and then you pick the 3 that has the smallest exponent. Well, remember there's that imaginary 1 there. So it's just going to be 3 to the first power. Now again, you don't have to put that first power. So what that means is 2 squared is 4, and 4 times 3 is 12. So 12 is the largest number that goes into 36 and 24. Okay? And you can kind of see that with this exponential notation. Because if I look at 2 squared times 3, do I see a 2 squared times 3 right here? Yeah, because this is really 2 squared times 2 times 3. Well, there's the 2 squared times 3 right there. So we know that 2 squared times 3 is contained in 24. And then we come over here to the 36, and do we see a 2 squared? Yeah, it's right here. There's the 2 squared. And then the 3 is contained in 3 squared, right? Because we can really write this as 2 squared times 3 times 3. So here's that 2 squared times, here's that 2 squared times 3 is right here, okay? So basically 2 squared times 3 is 12, and 12 is contained in the 36 and the 24, and it's the largest number that goes into both of those, hence the greatest common factor. Okay, well, let me do one more. Okay, so let's say I have 3 numbers now, okay? And you'll see why I'm taking my time doing these examples, because we're going to start adding variables to this, and we add variables, it's basically the same thing because variables have exponents on them, and we're going to follow the same rules. All right, so 40 is 4 times 10, 4 is 2 times 2, 10 is 5 times 2. Okay, so these are all prime numbers, right? So 40 can be written as 2 cubed times 5, right? And then 24, that's going to be 6 times 4, 3 times 2, 2 times 2. So this can be written as 2 cubed times 3. And then 60, 10 times 6, 5 times 2, 6 is 3 times 2. Again, let me circle all these prime numbers. Okay. And the reason why I'm circling them is because then I can really identify and say, yes, these are in fact prime numbers. And remember that a prime number is that the only number that will go into a prime number is 1 and itself. Okay, so like 10 is not a prime number because we know 2 will go into 10 and 5 will go into 10. But we know that 5 is a prime number because 5 will only go into 5 and 1 goes into 5. Okay, so let's write 60 into exponential notation, and that is 2 squared times 3 times 5. So the GCF, okay, what did I say to do? Write down all of the numbers that are common in each one of these exponential notations. So you do see a 2 in every one. So I put down 2. Do I see a 5 in every one? No, because 5 is not in 24, right? So I don't even list it. Do I see a 3 in each one of these exponential notations? No, it's not in the 40. So the GCF, the next thing that we need to do to get the GCF is pick the smallest exponent out of all 3 of these exponential notations for 2. Well, there's 2 cubed in 40, there's 2 cubed in 24, and there's 2 squared in 60. So it's going to be 2 squared. That's the smallest exponent on the 2. So 2 squared is 4. That means that 4 is the largest number that will go into 40, 24, and 60. Okay? So that's the GCF. All right? Now, let's apply this same concept, all right, the same concept to some variables. Let's say I have y squared z cubed and y to the 5th z. Okay? Well, the GCF, Okay, well there's no coefficients here yet. I'm going to put some on here in a little bit for an example. But here are the variables. So you look and see, well, what's common? Well, we know that y is common, and we know that z is common, right? So what is the smallest exponent on the y between these two? Well, it's squared. Okay. And, excuse me, what is the smallest exponent on the z? Well, it's 1, so it's just z. So this is the GCF, y squared z. All right? Okay, so I'm going to use these three numbers, okay, on the next example, but I'm going to throw in some variables here, okay? So let's say I have 40x squared y squared z to the fourth, and then I have 24 xy to the fourth z to the fifth, and then I have 60 x cubed y cubed z cubed. Okay, so again, let's go back up to here. 40, 24, and 60. So I don't need to do this again, but we know that the GCF is 4, right? So the GCF between the 40, 24, and 60, we know that that's just 4. Okay? So you would do that same process if this was the problem. You would break 40 down, 24 down, and 60 down into prime factorization, and then go through those steps, right? Now, let's look at these variables here. All right, well, what's common? Well, there's an x, an x, and an x. Okay, so x is common. A y, and a y. So y is common. And then a z, and a z. So z is common. Okay, so now you're going to pick the lowest exponent for all of these x's here. Well, we have an x squared, an x, and an x cubed. So it's just x. So that comes from this one right here. Then we look at the y. So y squared, y to the fourth, and y cubed. What's the smallest one? It's y squared. So that comes from this one here. So that's y squared. And then we look at the z. Z to the fourth, z to the fifth, and z cubed. So it's going to be from this one. Z cubed is the smallest. Okay? So my GCF is 4x y squared z cubed. Okay? So, why is this important? Or why do we need to know this? Well, let's do another problem. Okay? So let's say I had this problem. A multivariable polynomial. 40x squared, y squared, z to the fourth, plus 24 x y to the fourth, z to the fifth, plus 60 x cubed, y cubed, z cubed. So notice that I'm just using these same terms, but now I'm going and I'm just putting an addition sign between them. So now it's officially a multivariable polynomial. And if the question to this was, the question was to factor the polynomial. Okay, I want to factor this. All right, so to factor this, the first thing in factoring is you always want to take out your greatest common factor. That's why it's so important to know how to get the greatest common factor. So we've already done that. This right here is the greatest common factor for 40x squared, y squared, z to the fourth, 24x, y to the fourth, z to the fifth, and 60x cubed, y cubed, z cubed. Okay. So what you do to factor this is you take out the greatest common factor, which is 4xy squared z cubed. Then you're going to say, okay, multiplied by what to give me the same thing back. So in other words, if whatever I find in here multiplied by this greatest common factor better equal the original problem, which is right here. Okay? So, let me erase this. So you say to yourself, okay, well, 4 times what gives me 40? Well, I know that there has to be a 10 here. And then x times what gives me x squared? Well, an x. Excuse me. And then a y squared times what gives me y squared? Well, we don't need to put anything because there's already a y squared up there. Okay? Then z cubed times what gives me z to the 4th? Well, it's just a z. Okay? All right, now, 4 times what gives me 24? Well, we know that is going to be 6. Then x times what gives me x? Well, 1 does, but we don't put the 1 down, so we just leave it alone because there's already an x in the GCF, right? Y squared times what gives me y to the 4th? Well, that's y squared. Okay, see how important it is to know your law of exponents? You have to add the exponents together, right? 2 plus 2 gives me 4. Then z cubed times what gives me z to the 5th? Well, that's going to be z squared because 3 plus 2 is 5. All right. Then finally, 4 times what is going to give me 60? Well, looks like 4 times 15 is going to give me 60. Then x times what gives me x cubed? Well, that's x squared. Then y squared times what gives me y cubed? That's just y. And then z cubed times what gives me z cubed? Well, there's already a z cubed in the GCF, so we don't need to put anything there. So now, to check yourself, okay, so first let me go back. This is in factored form right here. This guy is factored, okay? All right. Now, to see if we did this correctly, you would just use the distributive law. You'd say this times this, right? Better give me 40x squared y squared z to the 4th. And this times this better give me 24x y to the 4th z to the 5th. And this times this better give me 60x cubed y cubed z cubed. Okay? And that's how you check yourself when you factor. You just multiply things out, and you better get your original problem back. Okay? So let's do a real simple one. Let's say we want to factor 3n squared minus 6n. Okay? Well, it's pretty easy here to look at the GCF between 3 and 6, so that's just going to be 3. That's the largest number that goes into 3 and 6, so that'll be 3. And if you look at n squared and n, remember you pick the smallest exponent, so that's just going to be the n. Okay? So 3n times what gives me 3n squared? Well, just n. And then 3n times what gives me minus 6n? Well, 3 times minus 2 gives me the negative 6, and then the n's already there in the GCF, right there. So it's just 3n times n minus 2. That's factored. Okay? Oh, let's look at another one. Let's say we have here 32x squared minus 8x, or 8xy, xy, plus 12. Okay, again, this is a multivariable polynomial. So what's the GCF between 32, 8, and 12? Well, some of these you could just do in your head. What's the largest number that divides into 32, 8, and 12? Well, if you just look at 8 and 12, you know the largest number that will go into 8 and 12 is 4. Okay, so does 4 go into 32? Yeah, it does. Okay, so that's it. So it's going to be 4. And then what about your variables? Well, do you see an x in each one of these terms? No. Do you see a y in each one of these terms? No. So it's just going to be 4 is the GCF. So it's 4 times what gives me 32? Well, that's 8. So 8x squared. And then 4 times what gives me minus 8? So that's minus 2. And then we have our x and y. And then 4 times what gives me 12? That's just 3. Okay? So this is factored. Now, every once in a while, you come into a situation that you may have to factor out a -1. Okay? So there'll be instances that you'll have to do that. So there will be times that you will need to factor out a -1. Something like this, right? Factoring out a -1. Alright, so for example, and I'll just write this here, factor out a -1. Okay? So if I have minus a minus b, well, if I take out a -1 as the GCF, okay, because if you think about it, there's really a 1 there and a 1 there, right? Excuse me. So if you take out a -1, you say -1 times what gives me a minus a? Well, that's just a. And then -1 times what gives me a minus b? Well, that's just a plus b. So notice if I use the distributive law here, -1 times a is minus a, -1 times b is minus b. So when you multiply this out, you get this back. Okay? We can even do this. What about a subtract b? Factor out a -1. So if I factor out a -1, I go -1 times what gives me a positive a? Well, negative times negative is positive, so I have to do a negative a, right? And then -1 times what gives me minus b? Well, it's just a plus b. And a lot of times what will happen, you'll see in your result that the negative can be switched, or you could reverse these terms and write it as -1 times b. So the positive term is first, so b subtract a. It's the same thing. So I'll just say this or this will work. Okay? Either one is acceptable, but it's kind of common just to write the positive value first. All right? And let's do 3 terms. Let's say I have -x squared minus x plus 16. Okay? And I want to factor out a -1, so -1 times what? Okay, well, -1 times x squared gives me minus x squared. -1 times positive x gives me a minus x. And -1 times minus 16 gives me a positive 16. So again, if I use the distributive law and multiplied all of these out, this overall result would end up just being this. Okay? Okay. Now the next concept we will learn here, and which was in the title for this section, is going to be factoring by grouping. Okay? All right. I mean, I could write out all this different algorithm, how to do it, but it's actually easier just to kind of show you what this factoring by grouping is. So let's first start out with this example, or we'll do a couple. If I have this, y times x plus 2 plus 3 times x plus 2. All right? Now just take a look at this. Do you see anything that's common between this and this right here. Well, you should see it. It's x plus 2, right? That's what's common. We have an x plus 2 and an x plus 2. So what is the greatest common factor between these two terms? Well, it's x plus 2, right? Because it's common. And it's the greatest one, actually. So if I want to factor this, I take out my greatest common factor, which is x plus 2, times what gives me this first term back? Well, it's times y, this guy right here. All right? And then x plus 2 times what gives me this back right here? Well, it's going to be the 3. All right? So it's going to be plus 3. So usually what will happen, you'll have your common factor right there, and then your other ones that are in front of each common factor go here and here. That's basically it. So that's factoring by grouping. Now it's not now these problems excuse me, are not all going to be in this form. All right? So we'll learn some different types of problems in a minute. But let's look at another one like this. So if I have AB times C minus 7 minus 12 times C minus 7, okay? If you look at these two terms here, this one and this one, what's common? Well, the C minus 7. So this equals to C minus 7. Then C minus 7 times what gives me this back? Well, it's the AB, right? AB. And then C minus 7 times what gives me this back? Well, it's the minus 12. And that's factored. So again, common factors go right here, which is C minus 7. Where the common factor goes here, which is C minus 7. And then just the AB goes here, and then the minus 12 goes right there. Right? And that's the pattern for factoring by grouping. Now, let me write this down. I'll say try using factoring by grouping when you are given 4 terms. Okay? For example, 6x squared minus 2xy minus 15x plus 5y. So you can see here 1, 2, 3, 4 terms. Okay? All right. Now, I'll say this many times, but since we're just kind of starting out, so the only thing we really learned so far is how to find a greatest common factor and then use that greatest common factor in factoring or factoring by grouping. But the first thing you always want to do at any time you're asked to factor something is you always want to look for the GCF, a greatest common factor. So if I look at these 4 terms, there is no greatest common factor. Okay, you can just see that between the coefficients. There's nothing common between 6, 2, and 15 and 5. Just nothing. All right, so we're done. So then you say, oh, well, there's 4 terms, so I can try this technique of factoring by grouping. And usually the way this works is you're going to just group, hence the name factoring by grouping. You're going to group the first 2 terms together, and you're going to group the second 2 terms together. And then you're going to actually factor the first 2 terms and then factor the second 2 terms. And you'll see what happens here. So if I look at the first 2 terms, the 6x squared minus 2xy, what's the greatest common factor between those 2 terms? Well, we know that 2 is. Okay. What's common? Well, there's an x and an x, so we can put down an x. There is not a y that's common between those 2. And then what's the lowest exponent on the x? Well, it's just 1. So it's just 2x. Okay? Sorry, I'm coughing. My allergies have been killing me. And anyways, a lot of coughing, a lot of sneezing too. All right, so 2x times what gives me these two terms back? Well, 2x times 3x, that gives me the 6x squared. And then 2x times, well, we know negative 1 gives me the minus 2, and then we have the x is already there in the greatest common factor, so it's minus 1y. But let's just put y there. Okay, there's no need to put that 1. You can, but there's no need to do it. Okay? So let's just verify. 2x times 3x is 6x squared, yes. 2x times minus y is minus 2xy. Okay, so we're good so far. Now I'm going to look at the next two terms, and I am going to say that the GCF, now usually I'm going to take up a negative, okay, so in other words, the GCF would be a 5, but I'm going to put minus 5 because of this negative right here, and you'll see why in a second. Okay, it wouldn't be wrong if you put plus 5, but actually let me put plus 5, because this is just a mistake usually people make. So if I put plus 5, and then sorry, before I do that, is there any GCF for the variables? No, there's nothing common. There's just an x and a y. So it is GCF would be just 5. Okay. Then you say, okay, 5 times what gives me minus 15x? Well, that's a minus 3x, right? And then you say 5 times what gives me 5y? Well, that's just plus y. Now, if you look at this and this, it's really close to being the same, but they're opposites. One says 3x, the other says minus 3x. One says minus y, and the other says plus y. So it's off by a negative sign. So what you would have to do, if you put plus 5 instead of minus 5, okay, you would have to do what we just said up here, and that is every once in a while, there will be times that you will need to factor out a negative 1. Now, this is an instance where you would have to do that. So if I factored out a negative 1 here, okay, so this is 2x, and I could have factored out a negative 1 here if I wanted to, but it doesn't matter. Okay, so if I factor out a negative 1, this plus 5, right, and I'll put, here's my negative 1 that I factored out. So let's ignore the plus 5 right now. So if I take out a negative, negative 1 times what gives me a minus 3x? Well, that's going to be a plus 3x. And then a minus 1 times what gives me a positive y? Well, that's a minus y. Okay? So 5 times negative 1, just rewrite this, is negative 5, and then we have 3x minus y. Okay, so now, after all that manipulation, we have common and common, right? So that's my GCF. So 3x minus y, there's my common factor, and then that's times your 2x, and then your minus 5. Okay? Now, usually what I'll do, and you'll kind of get this from experience, that I know that my next, in other words, this term over here, I know that it should be 3x minus y if this factoring by grouping would work. So if I pick the plus 5, I know, well, a positive times a negative is going to give me a negative, and you don't want a negative right here. You want it to be positive. So I know I would change the plus 5 here just to a minus 5. Okay? But if you didn't do that, you would just have to do an extra few steps by factoring out a negative 1. Okay? All right. Let's look at another example, factoring by grouping. And then we'll do a little bit more difficult one. So let me do one right here. Let's say it's 27mp plus 9mq minus 9np minus 3nq. Okay? So like I said, usually you would start out saying group these two together and group these two together. All right? So, out of these two, what's the GCF? Well, it's 9. What else is common is the m, and the m has the lowest exponent of 1, so that's it. So 9m times what gives me 27mp? Well, 9 times 3 gives me the 27. The m's already in the GCF, so it's just the p. Okay? And you just kind of visually do that in your head. 9m times 3p, does that give me 27mp? And yes, it does. Okay? And plus, well, 9 times 1 gives me 9. The m's already there, so it's just going to be a q. So 9m times q gives me 9mq. So my clue now is that that next part in parentheses over there, if factoring by grouping works, it should be 3p plus q. So let's see. Well, we definitely have a negative and a negative, so I definitely know I need to take out a negative. So it'd be minus what? Well, the GCF between 3 and 9 is 3. Okay. And then we have an n and an n and a p and a q. So the only thing that's common is an n. Okay. So minus 3n times 3p. So that gives me minus 9np. And then minus 3n times a positive q. So that's minus 3nq. Okay? And there we have our same common factor of 3p plus q. So this equals 3p plus q times what? Got to have that in parentheses. Well, 9m minus 3n. And of course, if you multiplied all this out, okay, you should check this. You should actually do this. So I would pause the video, multiply this all out using the distributive law, and you better get this right here. Okay? All right, now there's going to be times that it doesn't work when you try to group the first two terms together and the second two terms together. Okay? So I'll just put it doesn't always work to group the first two terms and the second two terms. Okay? Well, what do I mean by that? Well, let's say we have 5m cubed plus 6 excuse me, plus 5m squared plus 6m. Alright. Well, if you say, well, I'm going to group these two and these two, well, is there a common factor between 5 and 6? No, that doesn't work. So I just have to do some rearranging. So the most logical thing, if I looked at these two, I know I can get a common factor of 6, and if I looked at these two, I could get a common factor of 5 and m squared. So I'm going to rewrite this as 5m cubed plus 5m squared plus 6m plus 6. Okay? Now I'm going to group these first two and the second two. I group the first two and then the second two. Alright? After I rearranged them. So let's see. It's going to be a 5m squared, right? Because of 5 for the GCF for the coefficient here. And then for m cubed and m squared, the lowest exponent is a 2. Alright, so 5m squared times what gives me 5m cubed? Well, that's just m. And then 5m squared times what gives me 5m squared? Well, that's plus 1. Okay? So this is my clue. This all works. I should be getting an m plus 1 over here. So plus, GCF is 6. 6 times what gives me 6m, that's m. And 6 times what gives me 6, that's plus 1. And there we go. Okay. So from there, we know the GCF, oops, the GCF is m plus 1, and then just 5m squared, and then the plus 6. Okay. Then the last example I give, and this is kind of an interesting one, could really throw people off. Let's say I have 3t cubed plus 6t squared plus 15t plus 18. Okay? Okay, so right away you would think, oh, there's 4 terms. I can group these two and these two because there is a common factor in the first two terms. There is a common factor of 3 actually on the second 2 terms. So you might just jump into that right away. Okay, so if you go back a few minutes here, what did I say? The first thing that you really want to check before you jump into any technique is go back to the most basic thing and ask yourself, is there a common factor? That's where you always want to start. So let's see. Here's a 3 and a 6. So there is a common factor of 3, right? 3 and 6, common factor is 3. Is there a common factor of 3 and 15? Yeah. Is there a common factor of 3 and the 18? Yeah. Okay, then you have t cubed, t squared, t, and then there's no t on the 18. So there is no common variable. So my GCF is just 3. So I'm going to write 3 down. And then 3 times what gives me 3t cubed? Well, it's t cubed. 3 times what gives me 6t squared? Well, that's 2t squared. 3 times what gives me 15t? Well, that's 5t. 3 times what gives me 18? It's plus 6. Okay? Now here, we have 4 terms. So you can say, well, there's a possibility that we could use factoring by grouping. So if I look at the first 2 terms, I do have a common factor of t squared. So if I just kind of, see, I went into the motions here. Let's just say I have 3, and then common factor here is t squared, and that's going to be t squared times t gives me t cubed, and then t squared times what gives me 2t squared? Well, that's plus 2. So my clue is that there should be a t plus 2 coming out of this 5t plus 6. Well, right away that crashes because there is no, first of all, this is 5t plus 6, and there is no common factor between 5 and 6. So at this point, we are done. You cannot factor this by grouping. In fact, you can't factor it anymore. So this doesn't work, and my final result is just this. So there are times, okay, no matter how much you manipulate, you know, I go back to over, whoops, sorry about that, go back to what we did here. We just manipulated it, you know, one time. You know, if that didn't work, you'd try to associate 2 other terms together and do the factoring there. But there are times that things just can't be factored. So factoring by grouping may not work. And this is actually a case right here where factoring by grouping doesn't work. The only thing you could factor out is the GCF, which is 3, right? Okay, so that concludes this section 5.1 on factoring out a GCF, finding a GCF, how we find a GCF, and then factoring by grouping. Okay? Then we're going to get into a lot more techniques of factoring. Okay? So get this first part down, the factoring by grouping and the just finding a GCF. And that'll make life a lot easier for you when you get to these next couple more, 2 or 3 more sections on factoring. Okay?